So before we look at the next example and start using these laws of integration, let's just remind ourselves of fraction work, because this bit becomes important, as we'll see. We talked right at the beginning of the course about 2 divided by 3. Dividing by the number is the same as multiplying it by the reciprocal, 1 over it. Okay? So, although it's not written, this could just as easily be 2 divided by 3 over 1. Okay? And if we look at it, when I multiply it, I just invert this. So the 3 over 1 becomes 1 over 3. Okay? They invert. We multiply by the reciprocal. And this applies to any situation. So 2 divided by 3/4, for example. 2 divided by 3/4 could be written as 2 times the inverse, 4/3, and that's effectively what we do. You might remember from fraction work at school, when you divide by a fraction, you invert the bottom fraction and multiply, and that's what we're talking about here in a way. So the same applies to something that might look really awkward. 1 fraction divided by another fraction. 1/3 divided by 2/3. What do? We take the bottom fraction and invert it, so it becomes multiplied by 3 over 2. And then we look at this and we can see that actually we can cancel. 3's goes into 3 ones, top and bottom, so this actually becomes a half. Okay? A third, 2/3 of a third, 1/3 divided by 2/3 is a half. 1/3 divided by 2/3 is a half. Okay? We use this idea in integration. Let's look at this following slide. And this is in the textbook. It's a bit awkward, but I wanted to show it to you so you can see how it works. This is on page 457. Not that you need to look at it now, because here it is. If you look at the rule, if I integrate the square root of x, remember we have to rewrite the square root of x as x to the half. So what do I do to integrate x to the half? I add 1 to the power and divide by the new power, which is a half plus 1. A half plus 1 is 3/2, so it becomes x to the 3 over 2 divided by 3 over 2 plus c. But dividing by 3 over 2 is the same as multiplying by 2/3, inverting it. So this becomes 2/3 times x to the 3 over 2, or 2/3 times the square root of x cubed, plus c. So that's not a very clear example, but with that explanation, hopefully that makes it a bit clearer. The important thing to note here is this, look. Dividing is the same as multiplying by the inverse. So x to the 3 over 2 divided by 3 over 2 becomes x to the 3 over 2 times 2 over 3, or 2/3 of x to the 3 over 2. And that I'd expect you to do if you're applying this rule. If you're dividing by a fraction, invert and multiply. Yeah, they've been like that for a while, so. Right, let's look at some more examples. Integrate. Let's look at this together, okay? So following on from the notes, which was by way of introduction, let's look at some more examples. Integrate the cube root of x squared with respect to x. Remember how we say this? Integrate the cube root of x squared with respect to x. So x is a variable. So first step, integral of x to the 2 over 3 with respect to x. So I've not integrated it yet, so I just write it equals that. I've just rewritten it. So the rule we're going to apply is this one. Add 1 to the power, divide by the new power. So add 1 to the power. What's 2/3 plus 1? 5/3. 2/3 plus 3/3, 5/3. And divide by the new power. But then add c. Okay? So it becomes x to the 5/3 divided by the new power 5/3 plus c. But now, remember, we're dividing by a fraction, so what do we do finally? Invert the fraction and multiply. So this becomes 3/5 of x to the 5/3 plus c. Yeah, and then you can put it back into root form. 3/5 of, it's the cube root, because the root underneath is the cube root of x to the 5 plus c. Here, we need to think about what this means. It's not obvious what that is. Do you remember we were talking about, it tells us the area under the curve. So it would be whatever that area was. So we can't straight away just write down what that is. We just have to leave it as equals that. The integral of the function equals that. So finally we could write the integral of the cube root of x squared with respect to x is 3/5 of the cube root of x to the 5 plus c. Really, that's all we can do at the moment until we know what this means, this left-hand side. For this one, again, we have to start off by using the laws of indices. This is an inverse. The t squared is underneath, so what do we do about it? Right, we bring the t squared to the top and call it -2. The 3 stays underneath, so this becomes the integral of 5/3 t to the -2 with respect to t. So we use the law of indices again. Now, something that might help you at this stage is, this is something that I always sort of use, this idea. Actually, the constant can come outside the integral. It's just the t to the -2 that I'm interested in integrating. So we could take the 5/3 outside the integral sign and then just worry about that when we come to tidying up at the end. So that could be the way we can think of it. And then we just think about that first rule, which in words is add 1 to the power. There's the power. And divide by the new power. -2 plus 1 is -1. So this becomes 5/3 of t to the -1 divided by the new power, -1, plus c. So I just applied the rule. And now I take into account the 5/3 and try and simplify it. Well, that's just 5 t to the -1 over 3 times -1 is -3. But the t to the -1 means the inverse, so that means the t could go underneath. So finally it becomes minus, because the minus can go anywhere, 5/3t plus c. Easy to remember that c at the end. Forget that c at the end. Right, so page 416 in the textbook, Exercise 182, have a go at some of those. The answers are here. Some of them are very straightforward, some of them not so straightforward. Think about that one. We will look at some of them together. The way to go about something like this is to separate it. So 3x squared over x minus 5x over x, and then try and simplify it before you integrate it. As with differentiation, if I've got more than one term, I integrate each one separately. Doing something like this. Times it out, yeah. It's 2 plus theta times 2 plus theta. So I'd have to multiply out those brackets, and then I could do it, okay? So when you get to question 3, it starts to get more interesting. I'll put some more up on the board after a little while if you've not got the textbook here. 20 minutes, quarter of an hour, we'll take a break and then have a look at some of the examples after our break, okay?